What if you could learn a language just by watching movies? Not passively, but by truly imitating the lines, the emotions, the rhythm of native speakers. That's the idea behind Koenigstiger. From personal experience, I can't overstate how tremendously helpful learning a new language from imitating movie lines was. Koenigstiger aims to scale this approach to help more people learn from the screen. This is an OpenML project. We believe in open technologies. In the era of AI-assisted coding, we don't just open source code, we open our entire technology stack. At its core, Koenigstiger is built on two pillars: OpenAI Whisper, a speech recognition model pre-trained on over 680,000 hours of multilingual audio, and Hugging Face Transformers, the framework that lets us fine-tune Whisper for German. Whisper uses an encoder-decoder transformer architecture. Audio is converted into a log-mel spectrogram, processed by the encoder, then decoded into text with special control tokens like start of transcript and language tags. The Hugging Face implementation gives us full access to fine-tune every layer. But learning from movies means a unique acoustic challenge: emotional prosody, rapid colloquial speech, overlapping dialogue, slang, and environmental noise, music, street sounds, everything. Our data strategy is hybrid. The base layer uses Mozilla Common Voice for German, the gold standard of open source ASR data. Thousands of speakers, accents, and recording environments help prevent overfitting to a single clean sound. The specialist layer, our local collection of actual movie clips, is the crown jewel. That's where the real acoustic profile of German cinema lives. We'll cover the specialist data pipeline in a future episode. That's the foundation. Next up, the fine-tuning pipeline itself. Now let's look under the hood. The Koenigstiger pipeline is built from three distinct components, each with a clear responsibility. The architecture follows a simple principle: separate concerns. Data loading, model training, and orchestration each live in their own module. First up, the shard loader. This module creates a dataset pointing to audio with on-the-fly decoding in memory, but it's designed to grow. In future versions, it becomes a full multi-source data pipeline, pulling from local data, private data within OpenML, and shared datasets from Hugging Face. It takes all these raw inputs, normalizes them into a standard format, 16 kilohertz audio paired with text, and outputs a single unified dataset that the trainer can consume without caring where the data came from. Next, the training module. This is the actual fine-tuning component. It loads the processed data, configures the Whisper model for German, and handles the entire training loop, all through Hugging Face transformers. Finally, the orchestrator. This is the pipeline's entry point. It finds the compressed data archives, extracts them one by one into a temporary folder, kicks off training, and cleans up after each shard. Simple, methodical, reliable. Together, these three components form a clean pipeline. The orchestrator drives the process, the shard loader prepares the data, and the trainer fine-tunes the model. Each piece is independent, testable, and replaceable. That's the system design. In the next part, we'll walk through the training configuration and results. Let's talk about data preparation. Mozilla Common Voice for German comes as a single compressed archive, 34 gigabytes. That's a lot of data. And we don't want to pay to keep a static dataset sitting on a server forever after training is done. So here's the strategy. We rent a large AWS EC2 instance for just a couple of hours. Hundreds of gigabytes of disk space available on demand. The data gets downloaded onto that instance, uncompressed, restructured, and then the machine is returned. Pay only for what you use. The restructuring step is key. We break the dataset into shards, self-contained compressed archives. Each shard bundles everything it needs: the audio files and their matching text transcripts side by side. This lets us stream data into the training loop sequentially without random access seeking. which is ideal for storage-heavy training workloads. We size each shard between 1 and 2 gigabytes. Why? A 1 gigabyte shard of audio contains roughly 10 to 20 hours of speech. That's a substantial mini epoch for a specialized fine-tuning cycle on German data. And 1 gigabyte is small enough to download quickly from storage to memory, but large enough to keep the GPU busy for a meaningful duration, before the overhead of saving a checkpoint kicks in. So the full flow looks like this. Rent the instance, download the archive, uncompress, split into shards, upload shards to storage, and shut down the instance. Quick, efficient, and cost-effective. That's data preparation. The last piece, model versioning. Training machines are ephemeral. We need a reliable strategy to store and retrieve models after the instance is gone. Hugging Face is the obvious choice, but for a proprietary model, it carries real risks. Terms of service, data scraping, and outages. We don't need its social features. We just need a place to store large binary files. So we chose AWS S3, simple, durable, fully under our control. A model is just binary files, and S3 is purpose-built for that. Upload, version, retrieve, no middleman. And here's the result. Koenigstiger version 1, fine-tuned from Whisper Small, 244 million parameters, trained on a Tesla T4 with mixed precision. After 2 shards of common voice German, it hit 91% accuracy on movie dialogue, identifying words like Scharführer and Malheur that the stock model missed. A 10-point jump from 81%. We documented everything in a formal model card. The link for that model card is in the description down below. One key insight, aggressive learning rate on the first 2 shards for rapid adaptation, then conservative to prevent catastrophic forgetting. Training stopped at shard 3 when accuracy plateaued. That wraps up part 4 and this series. Architecture, data, training, versioning, the full Koenigstiger pipeline, open technology from OpenML. If you're building something similar, we hope this helps. Thanks for watching.